Okay, hey guys, so today I've decided to try and do a tutorial on the automated train I did a while back. This is just after they've created the new interface and everything for Gary's Mod. What is this now? Do they call it Gary's Mod 13? I'm not sure. The beta was 13 or 12. I have no idea. But either way, this is the new Gary's Mod, which messed up quite a few things, but I've fixed most of it, like wire not being available via the Steam Workshop, so when you go to add-ons and tools it's not there. I've installed some of the basic tools I use all the time. It's been quite annoying because you have to, for some reason I have to verify the integrity of the Gary's Mod cache every time I want to load the game, but yeah, anyway. And then if you have a look inside Advanced Duplicator, you see I've got all these dupes. These no longer work. The only one that does work is inside the Gmod 13 folder, which is this train. And that's because I rebuilt my automated train, well, a similar style to it, in the new version of Gary's Mod, because the previous one broke. And I had to rewrite the E2, because that also broke, because there's a new version of wire and nothing else works. So basically I've had to start from scratch, which is not useful, but anyway. So anyway, this is, if you've seen the original video, this is the automated train which stops at a station designated as black followed by red. That's a station for it. Detects the colours, stops at the station, waits for a certain period of time, goes through a station procedure, and then speeds along until it hits another station. It's a quite simple system. It looks complicated, but trust me, it's not. Anyway, so this is quite a big implementation of it. So I was going to do the same thing I've done here, well, for most of it, on this small setup here. So this is like the axis of this one, the axle of this one. So anyway, the first thing, which is the most important thing, will obviously be the expression I'm using for it. So I will post the expression code, the E2 code. If you can't read it in this video for some reason, if the video is too low quality, I will post it somewhere so you can read it in your own time. Alright, so if I just expand it, there we go, that's the entire E2 code. If you've never worked with E2 before, it's basically its own programming language, very simple programming language. Although, in fairness, I am using it at a very basic level. I know there's much more complicated implementations that you can do and more complicated code. You can do amazing stuff with E2, but this is a basic one. So anyway, you give it the name. I've called it AutoTrain V2. The inputs are just separated by spaces, so in this case we've got speed, time, color. The outputs are thrust, T-run, T-reset, doors, sound, lights, grab. And I'll explain what all of these do over the tutorial. Okay, so if we have a look at this code, so it says train stop, which is a comment because it's got a hash in front of it. So this is just the code for the stopping system. Then there's something called train reset, and this is when it hits the black section. So this one is activated when color is equal to 255. In this case, if it hits red color and it's fully red, that's 255 color. That's when the stop sequence is activated. When the color is 0, aka the black, because there is no red in it, we go for the train reset, which resets it before the station, so then it can stop at the station successfully. But yeah, basically it's very simple. I'll just run you through it and then we'll get on with using this code. If you don't want to listen to me do this, I'll put a time reference where you can just skip to and then carry on the tutorial. Anyway, so if you have a look, so if time is equal to 0, so this means that if our time is equal to 0 and color is 255, and the speed, so remember we've got three inputs, we've got speed, time, color. This tells us all we need to know about the current state of the train for it to then start, to then carry out the station procedure. So, okay, just to give you some idea of what they're doing. So here's the color, the wire colorer. This is what detects the train color on the side. Then we see, where is the timer? We have wire timer here, going to round just to make it round to seconds. And then we've got a speedometer, going to a gate round again. So basically we're just inputting the speed, inputting from a timer gate, and inputting the colour. So if we go back to the code, open that, just to give you an idea. Oops, there you go. Right, so the first thing we need to detect is if we fit a station, which is colour 255, I've already said that. Then, if timer is 0, now keeping in mind, when the train is reset, the black square, the timer is reset to 0, so when it hits it, it should be 0. Then we have to check for two things. We have to say, if speed is greater than 1, which it probably will be if it's going straight into the station at full speed, we turn the thrust to -1, which basically reverses the direction of the thruster, so it slows down the train. As soon as the train is equal to a speed of 1, or less than the speed of 1, we start the timer, which is T-run, and we turn the timer reset off. So the timer is able to run, it's not going to be reset, it continues going until we reset it and turn it off. So the next thing we have to do, so these are both irrelevant now, because we've turned the timer on and we've stopped at the station. So now we say if time is greater than 0, basically after the timer has been activated, we say the thrust is 0, because we don't want our train to accelerate whilst we're trying to stop at a station. We say the grab is equal to 1. Now, if we have a look at the grab, there are 3 grabbers on this train, although 1 would suffice, but 3 grabbers is more stable. Basically what they do is they will hold the train securely in place at the station. They grab onto the floor underneath the rails, and make sure that the train can't go anywhere whilst you're in the station. Even if it gets hit by something, I don't know. Right, so, okay. So we open the doors, we turn the warning light on, and we turn the warning sound on. If time is greater than or equal to 10, so after 10 seconds, we close the doors. If it's greater than or equal to 12 seconds, we turn off the warning light and the warning sound. If it's greater than 15 seconds, we turn the grab off, so we release the train, and we turn the thrust on, so the train starts to leave the station at 15 seconds of the timer. So what happens when you hit another station? Well, the first thing you do is you're going to reset the train. So it's going to hit the black square, which is colour 0. It's going to stop the timer. The timer is going to be running all that time when it's out the station, so we want to reset it back to 0, so it's ready for when it hits this point again in the code. And then timer reset is equal to 1, and that just keeps it definitely at 0, just in case. I mean, it's not necessary, but we need to reset it anyway, otherwise it won't be at 0, obviously. Okay, so hopefully you understand what it's actually doing here, if you've listened to me go through this code. So anyway, just to give you an idea, the doors are obviously these things here. They're based on wire hydraulics, and that's very basic, but you have issues with these sometimes where the hydraulics totally spaz out, and it took me quite a while to get 4 doors which actually work and don't spaz out when you move them. So these are I was quite lucky with that. Anyway, so we've got the warning sound, which can be any sound you want. It's just there to warn when the doors might be closing. This is the sound for the train when it's moving. I'll get onto that. And these are the warning lights. So if I give you an idea, okay. So if I take the station, well, what you can call a station, and pass it by the wire colorer. So initially we reset the train, so you can see it's black. It's hit the black. Then we move it along. It's hit the red. So you can see, doors have opened, warning sound is going, it's grabbed the floor. So the first thing it will do is it will close the doors, turn off the warning sound, and then accelerate again. So as you can see, if we wait for it, there we go. Close the doors, warning sounds turn off, grabbers turn off, and the timer will remain running until it hits black again, and we can see the time has stopped. Okay, so that's a more advanced implementation of this basic system. So we're going to move on to building our own automated train using this small setup here, and that station over there. Okay, so the first thing you want to do is you're going to write that E2 I've provided, and that means you've basically got most of the coding behind it, the logic behind this train already. So you're going to place that somewhere in the center. It doesn't actually matter where you place it. You'll then want to go to wire render, click colorer. You select any of the models. You want the range to be about 75. You want quite a small range. You don't want it to detect stuff like a few miles away. But yes, anyway. Then you want it to say output color, which is very important. So that means it can detect color as well as make things a different color, because we're going to be detecting color. So anyway, then just place that on the side of the train that's going to hit the station and the station colors. Okay, so the next thing we want is a speedometer. You want to go to wire detection speedometer, untick both of these so they're both unticked. If they are ticked, you'll put that next to the E2. Then you want to go to gates. So the first thing you want to do is go to time gates, select timer, put that near the E2 as well, because that's only going to be referenced by the E2. Then you want to go to wire arithmetic. You want to select round. Now you want to put 2 round gates, so one for the speedometer and one for the timer. Okay, and then we want to go to wire advanced. Okay, so speed, our speed input into the expression 2 will go to the round, and the round will go to the speedometer, and you want to select miles per hour. Or kilometers per hour, it doesn't actually matter, but I work in miles per hour, so I'll go for miles per hour. Okay, next thing we want to do is take the time of the E2, send that to the round here, and send this round to the wire timer. The final input we need is color. So if I put this around here, so I want to send it to this one here. I'm just making it look neat, that's why I've got the wire going all over the place. You select this, now you see you've got RGBA. R is red, G is green, B is blue, A is alpha, which is level of transparency. You want to select R, because that's what we're detecting how red the object is, in which case it should be 255 to activate it. Okay, so we've got all our inputs now. The next thing we want to do is to control the timer. So we're going to take the timer run input, take it to here, and do T run. That's our timer run. You can see it's already running because it must have detected some red. Next thing we want to do is take the input reset from the timer, bring it to T reset. So our timer gate can be fully controlled by the E2 now. The next thing you want to do is take the wire thruster. Oh, my apologies, you do need to make a wire thruster. This is going to propel the train. You could use the wheels in this case to propel the train, but I find it much easier to use the thruster because the wheels sometimes don't work too well. There's issues with slipping and friction not working, whereas thrusters always work, as long as they're not too strong and make your train flip off the rail. But anyway, so you want to take the input A to the wire thruster and select thrust. So now we can control the thruster. Okay, so the rest of the things on there. Okay, so if we just do one final part, which is the grabber. So you want to go to wire physics, max range about 100, tick disable gravity. I don't even know if you need that, but I just have it anyway. So we want to put this under the train so it can grab onto the rail as we're stopping. So then we want to take grab and send it up to the top, to the E2, and we want to take it to the grab input, if you see there. Okay, so you've noticed, before I press grab, you notice how we haven't used doors, sound, lights. Now these are all superficial, they just make the train look better. The train only needs thrust, T-run, T-reset and grab to work outputs, and it needs all three speed, color, time to work. These are the only things it needs to work. Doors, sounds, lights will not affect it, but obviously as you want to run a good train, you will want these to make it look good. But in the meanwhile, for this tutorial, we will not look at those just yet. Okay, so we've got our basic train. This should work immediately. Fingers crossed. Okay, so let's just check it's the right height. I'm just making sure the station will be detectable. So let's say it's about there. Okay, so if we let the train go, okay, so I've turned down the thrust because I want it to be obvious, observable, and not mess up. Okay, so you notice how the train stopped itself. It's grabbed the floor. Now in the meantime, the doors would open, the lights would turn on. Now the doors would close. Now the lights would turn off, and it should ungrab and head off again. See, it's already working. That's as much as you need to make it automated. You can make a little circuit loop and have it running around. Okay, so that's basically done. You can then implement it into a big, the entire train using the same system, just on a bigger scale. That's basically it. So, okay, I've got one more tip before I, basically finish this tutorial. This is about the doors. Now, the door output on this is 0 and 1. Obviously, you need to multiply this value for 1, because the hydraulics won't be of length 1 when it's closed, and 0, it will be 0 when it's open, but not 1 when it's closed. So you need to multiply this by whatever amount it is, like in this case it's 142 on each side of the door here, to close them. But if you want to make it look more realistic, so just to give you an example, so they open slowly going to fast, and then they close slowly, close fast going to slowly. Now what I mean by that is, if you noticed when I opened them, they started opening slowly first, and then they got rapidly faster towards the end, and then oh dear, I accidentally moved that one. They started fast and they stopped slowly. So there we go, roughly there. Basically, it's just to make it look nicer again. All of this is superficial now. It's not about how the train works. It's just to make it look nice. Okay, so if we have a look at the code, well, I'm not even the code, the gates for this. I'm using a wire button here. As you can see, it's toggling between 0 and 1, which is exactly what the E2 does. So you can basically take these gates, this gate setup, and use it on your train almost immediately with little edit. Okay, so you see when it's 1, we've got a series of gates which keep closed, and when it's 0, it will open. And these gates also control that. Okay, so it all comes down to 2 smoothers. So we have one smoother here, one smoother here. Now, what this basically does is the first smoother has a fixed rate. So you see here we've got 0.49 as the fixed rate. And then going to this one, we send the rate of this smoother into this smoother. Now what this is doing is this smoother gradually gets larger or smaller as the door opens or closes, and this changes the rate of smoothing for this smoother, which actually controls the doors properly. This one is just to control this smoother for this multiplier to then go to the hydraulics. It's kind of difficult to explain in words, but if you look at the, if you work with it yourself, you will understand how easy it actually is. So what we do here is we have a NOT gate, which turns, so if this is 0, this turns to 1, and if this is 1, that turns to 0. Now, to understand what that is doing, basically, so when this is 1, for example, we're closing the doors. So this becomes 0. This means that this value starts to decrease, which goes into this value smoother, which means that as it closes, the rate of smoothing, the rate of change becomes smaller as time goes along. So the rate that the doors close becomes slower and slower until it actually closes. So this is why we get, when we press this, notice how it becomes much slower at the end as opposed to the beginning. And in reverse, starts slow, becomes fast. And so we send this smoother, which is controlling both of them, into this multiply. And these both go into the hydraulic controllers for the wire. So in this case, I used 142.84, that's just whatever they were before, to multiply the smoother value. So that's when you press closed, that's how far the hydraulics go to on each side. And 0.49 is the smoothness rate. Now, depending on how far the hydraulics have to travel to close and open, you will have to change this value of smoothness, and that's because, for example, I'll just give you a demonstration of that. So if I do this, let's say I change it to 0.7. Now let's say I want to try and open it, so if I do this, that works fine. When I try to close it, however, you notice how the smoothing here is already 0. Now that means the rate of change of this smoother is now 0, so it's not going to change anymore, so the doors are just going to halt midway and not do anything, and that's completely stuck now. It does open again. That's fine. That was fine, because obviously the smoother is increasing, but this will never close properly. But as soon as I change the value, decrease the value to like 0.49, which I found to be basically perfect for this setup. If I open the doors again, close them, you notice how it gets all the way 142.84, which is what I wanted, and that works perfectly. If you have it too small though, it won't look that much different if you didn't have the setup at all, basically. So 0.2 is kind of slow all the way, and this one is fast all the way. So it's a very odd system. So you just want to find a good value, basically, and it's roughly going to be around where I got it currently anyway. Constant value. There we go. Okay, so this is a very basic tutorial setup just to show you, what you can build in terms of the automated train. I hoped it helped in, you being able to do it yourself. So I'll just show you what this one does to give you an idea of what you can build. Right. Okay, I might have to extend it. The problem is this train is so heavy that it might not stop in the station, so I'll have to extend it. Front, behind, there we go. Perfect. Okay. Now, due to the dupe messing up my train as usual, it will lean to one side constantly. That's due to some sort of world being bad or axes going wrong during the dupe process. So, there we go. So if we have a look, yep, it's going to lean to one side. Oh dear, oh, whoa. Okay, take 2. Let's see what happens now. This should work properly this time. I've checked it. Right. So the train is stopped. Doors are opened. Warning sound is on. So it allows people to walk in and out. You can sit down. Now after a certain period of time, there we go. Doors close. Everything switches off, grab is open, thrust goes. And there it goes. Off into the distance, there it goes. Okay, anyway. So that's the tutorial of how to build an automated train. I hope it was useful. It means that you can build very basic setups. I mean, as far as it goes, this is probably the most basic setup you could ever produce. You'd probably have to put a chair on it or something, so... but yes, you can go as complicated as you want, but the framework is basically always the same. You can make little additions to it, do different things superficially, but the logic should always remain the same. So anyway, I hope this helped, and I will see you next time.